All right, everyone, this is the Bridge for Math. Dr. B coming at you with Get It, a real-world application. We're talking population growth in Mexico using exponentials and logarithms. So in math and engineering, it's nice when we see how the formulas and everything actually apply to life and how they can be useful. So let's check this out. Here's a really powerful formula that you'll see in different forms in math books and science books and different textbooks, even finance books and economics and business and different disciplines. The formula is usually given something like this, where on the left side you have some future amount of something. It could be money, so again, I want to catch your interest. This formula works very well for how long it takes to double your money. You have this A0. Teachers pronounce it A naught. A0, that subscript 0 means at the beginning or start or time equals 0. A equals A naught, just letting you know it's the same type of population, where this is the population in the beginning, this is the population after a certain time has gone by, future amount, times E. Don't let E scare you. E is just like pi. It's a constant. It's called Euler's constant, or approximately 2.718. Raised to a power, R times T, where R is the rate of return or interest rate. In decimal form, it's key. Most people forget. Put it in decimal form. T is time. Make sure you remember the units of time. This formula is in time units of years. So you have this formula. And I hope you look at it and say, well, I don't see any logarithms. You're right, it's not in logarithmic form, but do you see exponents? Yeah, you do. So it's exponential form. And if you're trying to solve for R and T, it's called an exponential equation or a transcendental equation in math. Heavy word. Well, let me give you a few other pointers. Usually you hear this, you'll hear about exponential growth or decay. Growth means it's getting bigger, decay means it's getting smaller. If this R is a positive number, that means it's growing, it's getting bigger. But if your R is a negative number, that means your population or something is declining or getting smaller. This example works for carbon dating, like how old something is, a bone, you find dinosaur bones, lots of different great examples that if you follow this well, you can solve in your math courses or science or applied courses. So let's look at the particular question. You have a population growth model where A represents Mexico's population in 2006, in millions. A is equal to 107.4 times E raised to the 0.012 times T power. So we have this formula. You need to know all the letters. E, is just a number, 2.718. A is the Mexico population of the country of Mexico. T is time after the year 2006. See, when the word problems, half the problem sometimes is you don't read it. So you want to make sure you read it. What are the letters? Input and output. So think function, input, output. So what was Mexico's initial population? They asked you that question. What was the initial population? Oh, what does initial mean? That means the starting population for this model in 2006. So literally, it's going to be your A0, or the number in front of the E. Well, you can do it a couple different ways. You can just say, well, that's the number in front of the E, so it's 107.4, and you'd be right. But what if you didn't remember that? How could you apply this formula? So notice they say the population in 2006. Well, what is T going to be in 2006? Well, T is going to equal 0. Because 2006 is 0 years after 2006. So it's basically at the beginning, at the start. So you plug in 0 into your formula for where the T is. Notice your population in 2006, you didn't have to put 2006 there, I like to let you know what you're doing, is equal to 107.4 times E raised to this power. Well, what happens when you multiply 0 by anything? Exactly, it just goes to 0. Well, here's another tough question. Anything raised to the 0 power, except 0, let's not go there. But E raised to the 0 power, or 2.718 raised to the 0 power, that is equal to 1. So it's 107.4 times 1. So this is another way to solve that exponential equation for the population of Mexico in 2006, 107.4 million people. Now, do you think people who study world population growth, farmers, people who work with populations, doctors, do you think we care about population growth or a population doubling? Absolutely. All the resources that could be used. Did you hear that baby in the background? We're talking population growth. So let's check this out. Time to double population. Let's look at the facts. A0 equals 107.4 million. We talked about that. That was the population in 2006. What's the percent growth? It's 1.2%. Seems like a small percent growth, but it's positive. So even at 1.2%, so think of money in a bank account, that's puny percent, 1.2% growth per year. Well, in decimal form, that's 0.012, that's your R. What does it mean to double your population? Well, it means you're doubling 107.4 million, it becomes 214.8, so you doubled the population. Let's take all this information, plug it into the population growth model they gave you, and you get this. What's the only unknown? You have one equation, one unknown. That means you're looking good. We're trying to solve for t. Notice I put t in sexy here. That's what we're looking for. What's the hard part about solving for t? It's an exponent right now. That's what's hard about it. So let me give you a hint. This is one thing, you know, order of operations. Well, I can tell you this. Before you even start order of operations, if you have anything being multiplied, you can divide both sides as long as you do to the left what you do to the right. You can get rid of this initial constant in front of the e. So I divided both sides by the 107.4. And lo and behold, what's on the left side? 2. What do you think the 2 represents? That you're doubling the population. What's the only thing left on the right side? You have e raised to this particular exponent. Now again, we need to bring this t down to our level of solve for it. So how do you bring it? How do you bring an exponent down? Do you remember anything in your mathematical tools that allows you to bring an exponent down? Yes, taking the logarithm or the natural logarithm of both sides and using the power property. So look at this. I'm taking the natural log of 2, so do it to the left, and I'm taking the natural log of this, e to the 0.012 t power. Now that there's a natural log being applied to it, literally where these become the inputs, careful, this is not multiplication. This means take the natural log of input 2. This means take the natural log of input e raised to this power. Well, per the power property, what can I do to this exponent now? Bring it down in front. Now the t is at our level, and we can take it out. So look at simply now, natural log 2, you're going to get this from your calculator. Turns out to be 0.693. The 0.012t, that's what we're trying to get t by itself. But what's natural log of e? Well, natural log, if you remember, is log of base e, of input e. That's simply 1. And by the way, you could have taken the logarithm on both sides, and just been one extra step. But by taking the natural log, you know this immediately goes to 1, it cancels out. So let's look at what we're left with. Now, does this look like an easier equation than when you started? You have 0.693 equals 0.012t. All I have to do is get t by itself. That's the answer for time to double the population. So I'm going to divide both sides by 0.012. T is simply this fraction. You do the math, get your calculator going. You have 57, approximately 58 years. If you don't get the exact answer, don't panic. It's probably round off error. But you agree you have an estimation of about 58 years for the population of Mexico to double, according to this model, if the growth rate's about 1.2%. So I hope that helped you out. This is the Bridge for Math checking out for you. Good luck with all your questions, and we'll see you next time.